Our galaxy, the Milky Way, is big. Estimates put it at about 100,000 light years from one end to the other. But you know what's way bigger? Space itself, because in all of that space, we estimate that there are as many as 100 billion galaxies. And among all those galaxies, we found a few that are our twins. That's right, the Milky Way has long-lost twins out there among the stars, although not in a literal sense like our galaxies formed in the same place at the same time. But finding these twin galaxies can help us learn about our own, because it's pretty hard to figure out what's going on in the Milky Way while we're a part of it. The Milky Way's disk is 1,000 light years thick, and to get a good picture of it, you'd have to get pretty far above it, like how the Earth is round, but you wouldn't see the curve unless you were way above it, even higher than commercial airliners go. And cue the flat earthers in the comments. Now, considering that the Voyager 1 spacecraft, the most distant man-made object we've ever made, is about 0.002 light years away, we're not taking a galactic selfie anytime soon. To borrow a metaphor I wish I'd thought of, mapping the Milky Way is like trying to map a forest while you're tied to one of the trees. So we've had to piece together what our galaxy looks like based on what we can see. First and most obvious is the Milky Way is flat because we can see it edge on in our night sky. The shape of that flat plane has been a bit harder to pin down. The astronomer Herschel was the first to try it in 1785, and by counting the number of stars he saw and assuming that more stars meant more galaxy, he came up with a pretty blobby shape. This picture changed in the 1910s when another astronomer, Herschel Shapley, measured the distance to globular clusters of stars and found that they were in a spherical shape about 100,000 light years in diameter. Shapley concluded that our galaxy must be a circular disk inside this spherical halo of globular clusters. In the last 75 years, techniques that could see through interstellar dust like radio, infrared, and X-ray astronomy have helped us see just where the arms of our spiral galaxy are. But there's only so much we can do from here. Exactly what the Milky Way looks like on the other side of its central bulge is unknowable to us, and our image of what we can see is still changing. We only started to realize that the central bar connecting the large spiral arms was thicker and more substantial than we thought in 1996. So, now that we have a pretty good idea what we look like, we can seek out similar galaxies that can fill in the gaps. NGC 1073, for example, is a barred spiral in the constellation Cetus. Another twin, Gamma 202627, has two smaller companion galaxies, much like our own Magellanic Clouds. Companions as big as these clouds are a rare find and warrant further study. We've even found a galaxy that could tell us about the Milky Way's ominous future. Near Andromeda is a small and incredibly dense galaxy called M32. A recent paper proposes that once upon a time it looked like the Milky Way, until Andromeda came barreling through, stealing stars and planets, ballooning in size, and leaving M32 a shadow of its former self. Why is this important, you ask? Because Andromeda is on a collision course with our galaxy. What happened to M32 could be what happens to us. Odds are good that as our telescopes and techniques improve, we'll find more of our twins out there that can tell us more about ourselves. Just don't get too attached to the galaxy's shape, because in about 4.5 billion years, it could all change. Fun fact, confirming the Milky Way had a large bar also meant our galaxy had two large arms that wrapped around it twice, rather than four separate main arms as previously thought. If you like this video, go check out this one Marin did on the universe's first type of molecule. Thanks for watching, don't forget to subscribe, and I'll see you next time on Seeker.